Welcome to the fourth project of the SparkFun Inventors kit with MicroPython, displays. We are going to be using the quick OLED from your kit to display one of the most common phrases in programming, hello world. A display is simply an output device for presenting information visually. There are many types of displays, from OLEDs to LCDs to old cathode ray tube televisions. Even LEDs could be considered a very simple form of display. The display that comes in your kit is an OLED, or OLED, which stands for Organic Light Emitting Diode. It contains a layer of film that emits light in response to an electric current. It is split up into a grid of little squares called pixels. Since our display is monochrome, each pixel of the display can be set individually to white or black, allowing us to display anything from text to even lines and shapes. If you're tired of having to make tons of connections with jumper wires on your breadboard, don't worry. This circuit only requires you to connect one cable, the Quick Connect cable. This single cable has 4 wires, one for power, one for ground, and 2 that are used as the communication signals to talk to our OLED display. What language do computers speak? Well, in ones and zeros, of course. We've already played with PWM to create square waves that alternate between high and low with different frequencies and pulse widths. A device communication protocol is a way that devices can set signals high to communicate a 1 and low to communicate a 0. By combining ones and zeros in special ways, the devices can communicate entire messages to each other. You can think of it kind of like Morse code, where entire words can be sent between people by just sending a series of dots and dashes. I2C, also known as I2C, is a very common communication protocol where devices put ones and zeros on 2 different wires to talk to other devices. Many SparkFun devices speak in this language, and that is why the Quick Connector was created. It easily connects together devices that communicate with I2C. That's about it for theory for Circuit 4A. Now let's build the thing. Just a heads up, this is going to be the easiest circuit you build in the entire kit. The old version of our kit used a different type of display, an LCD with a parallel interface instead of I2C, which required, well, a lot of connections. This kit saves you all that hassle by using an OLED with the Quick Connect cable. Connect one end of the Quick cable into either of the Quick connectors on your OLED, and then connect the other end to the Quick connector on your IoT Red board. The connector is keyed, which means it will only connect in one orientation. If it's not clicking into place and staying connected, try flipping it 180 degrees. Notice how we don't even need to use the breadboard at all in this circuit, since all 4 of our necessary connections will be handled by the Quick cable. Now let's run our code. I2C is a pretty complicated communication protocol, and that's why we are going to rely on the Quick OLED package to handle those low-level details for us, so we can spend our time inventing instead of getting into the nitty-gritty details. In our first cell, we'll set up our OLED, and in the next cell, we'll initialize it, and then print our message, hello world. When learning a programming language, it's often actually tradition for the first program you write to simply print the phrase hello world. Up until this circuit, though, we haven't had a screen to display this message, so we'll do it now. When I run the second cell, we can see our message get displayed on our OLED. Good job in completing Circuit 4A and learning all about displays and communication protocols. I hope you enjoyed your little break from the breadboard and that you now understand just how useful the Quick Connect cable can be. Join us in Circuit 4B next, where we'll be designing a digital thermometer.